Maybe we can begin to talk about citizen science. Thank you for your attention.
Thank you, Anne, for sharing the Ugandan perspective and how you are tracking your coordinators. That was quite informative. So now I'll call Jane from National Museums of Kenya. She's going to talk to us about honeybees. From her study on what they are doing in Nyandarua. I think this will be very important for us to do. Thank you.
Thank you. Good morning, everyone. My name is Jane Macharia. I'm a research scientist here at the National Museums of Kenya. I'm based in Zoology Department, Center for Bee Biology and Pollination Ecology. I'm going to present work that we did with a team that is including Professor Mary Gikungu, the current DG NMK, Dr. Itambo Malombe, and Josephine Cha. They are all research scientists here at the National Museums of Kenya. Just to mention the importance of honeybees and beekeeping, that if you ask the forest dwellers, like Ogiek community, honey is food to them. And also contribution from research, it has shown that there is a great yield in terms of quality and quantity. So it's a good, it enhances food security. And also when you look at the community, that is a team from Nyandarua County where we issued some beehives for them to start up the beekeeping activity because it contributes a lot to their livelihood. Also, pollination, many crops and many researchers have done this, and it's evidence that including pollinators, the bees and other pollinators such as butterflies that have just been mentioned by Dr. Kioko, they contribute a lot to pollination, and this increases the quality and yield of the products. Apart from that, you don't have to be a beekeeper so that you can enjoy in the beekeeping industry. Along the value chain, there are several actors, and these also improve the economic growth of the country from that industry of apiculture. This is through maybe making of the hives and other equipments that are needed in the apiculture industry, as well as you can choose to be an actor in the enterprise, selling of the beehive products, including honey and other products such as propolis, among the rest. So our studies, we did it in Nyandarua County, specifically at Old Jororok and Kinangop. The study sites were chosen based on the project target areas, that is through KESA project. The status of beekeeping in Nyandarua, as you can see from that, there is a lot of increased floral dearth. This is the loss of flowering plants that provide the nectar to the bees that give yields to the honey. There is also a lot of unpredictable extreme weather. This may be cold, heat, and so forth, that is affecting a lot in the beekeeping industry. As a result, also because of these unpredictable extreme temperatures, there is a lot of bee absconding. And also there is issues of theft of beehives as well as honey, and not to mention about the hives. You find most farmers who are doing the beekeeping, they have very dilapidated types of hives, as well as very traditional. I don't mean that traditional hives are bad, but with the current modern technology, the traditional hives have been modernized, like maybe to include the excluder, queen excluder, so that during harvesting, you are able to get quality honey. As a result of all these increase, there has been a decrease in honey production, because without good hives with bee absconding and the floral dearth, we don't expect to get any good harvest. There is also loss of bee floral diversity. Bees, especially the honey bees, they are generalistic feeders. They'll feed from a variety of flowering plants. And when we have that low diversity of flowering plants, definitely it will lead to low production of honey. There is also issue of the monocropping. Most of the farmers in Nyandarua, they are practicing monocropping, and especially wheat production. Wheat, it's a self-pollinating crop. So most of our bees, they lack floral resources where they can get the nectar and the pollen. And as I mentioned about the beehive technologies, they have not modernized their traditional hives to take care of quality and yield production at the end of it all. And also the level of the capacity of bee management in Nyandarua, it's a little bit down. So the natural setup of the beekeeping in Nyandarua, especially during the extreme weather conditions, it's like this. As I mentioned, there is increased flow of the earth, temperatures as well. All these leads to reduced colonization of the hives, as well as increased rate of absconding. Insecurity is a major issue, and access to water for the bees. So the project looked at, are there potential for beekeeping in Nyandarua? Yes, they brought the issues of establishing managed bee climate smart pasture, as well as establishment of climate smart bee housing to provide solution to the problem that are facing the beekeepers in Nyandarua. What do I mean by climate smart bee house? As I have mentioned, one of the major problems that Nyandarua beekeepers are facing is those unpredictable extreme weather. And these has resorted to a lot of bee absconding. And at the end of it all, the production of honey in Nyandarua is low. So by providing them with a climate smart bee house, this will help them to have their bees together. So it will ease the monitoring and also the temperature, because they are providing shade to the bees. And also when we talk of managed climate smart bee pasture, this is whereby near the apiary where they have put up their climate smart bee house, they are putting up a pasture which is climate smart bee pasture. What do I mean by that? After research done, they have identified several plants that are pollinator dependent, or bees are foraging for, and they are resilient to the climate of that particular area. So these are the particular crops that are planted near the apiary. So what does that mean? The bees will not moving very far from the nest looking for this food. And by so doing, these are resulted to high increase of colonization as well as end product, which is honey. So during this study, honeybees were sampled from both the managed climate smart bee pasture as well as the natural habitat. We also looked at the flowering plants that were managed at the bee pasture as well as those which were at the natural sites. And also we looked at the occupation rate in the colonization at the bee house to the hives that were put in the bee house. What did we find? Managed bee pasture plot recorded the highest number of honeybees that were foraging as compared to those that were in the natural sites. It was also found that the Osmium climadascalicum, this was the major crop that was highly visited by the honeybees in all the managed sites, while the Consia and the Malvaceae species were found in the natural ecosystem. And within the period of 2 months when this data was collected, more hives were occupied in the managed site as compared to the natural sites. So in conclusion, we said honeybees are sensitive to habitat, as it is clearly indicated from the natural habitat as well as the managed habitat. And therefore, their population are factors of plant diversities. Also, we conclude by saying the managed climate-friendly bee plants, the climate-smart bee pasture, could lead to reduced rate of bee absconding, because bees are absconding because of lack of resources. So when these resources are provided near the apiary, the rate of absconding is minimized. And therefore, we recommend adoption of this climate-friendly bee pasture, so as to and also the climate-smart bee housing for high production of honey. Areas of collaboration. We identify some gaps that we need to collaborate to make this research more practical and yielding. One, it's in the identification of bee plant suitable for each ecological zones. It will be prudent if all the ecological zones in our country, we have a checklist of plant floral resources that are used by the bees. Also, coming up with the calendar, the floral calendar, when and which plant species are flowering at which particular time. These will help us now to generate the geographical indicators of our Kenyan honey. Just like coffee, why coffee, the Kenyan coffee is so selling is simply because of the branding. Our Kenyan honey is not well branded simply because we cannot tell the origin or the attributes in terms of where these bees are foraging from, because honey, it's about the plant where the bees have foraged from. Just to acknowledge the community we worked with from Kinagop and Nyandarua in the KSAP project. Thank you.
Climate smart bee pasture, climate smart bee housing, yeah? Those are new terms that I've learned today. I think I will try and read more about it. So next, I think we'll go to Kenyatta University, Mary Stella. Mary Stella will talk to us about floral calendar and honeybees. Karibu, Mary.
Opened it up a few minutes ago. You had opened it. There's a time you open it when you're looking for that. Ah, that one. Yes. The first PowerPoint.
Okay, you have 8 minutes.
Okay, I'm Meristella Wehanya, a student at Kenyatta University. My supervisors are Dr. Moa Kasina, Dr. Karanja, and Dr. Mary Guantai. My research is on the was on the floral calendar of flowering plants and honeybee resources in Machakos County. That is the outline of my presentation. The introduction, we know that pollinators are very key in the biodiversity, ecosystem services, and agricultural systems. And as you've been told, we know that the main pollinators are normally bees. And it's been noted that in North America, there's reduction in both wild and domesticated pollinators, resulting to a decline in plants that rely on them. Honeybee decline is a threat to agricultural production and conservation of biodiversity. My research work was on the farmers that, the smallholder farmers that farm pumpkins. That's why I have a photo of a fruit of a pumpkin, and on the other end we have, there's a photo of a bee visiting a flower of a pumpkin. The problem statement is there's a global decline in honeybees due to anthropogenic factors, and climate change has increased the vulnerability of pollinator-dependent crops. The crop production has also reduced due to insufficient pollination caused by decline in floral resources for the bees. The floral calendar of some bee flowering plants is not known, and alternative plants could enhance pollination. Alternative plants that could enhance pollination have been ignored, and some have not yet been documented. My justification, there's a lot of over-reliance on maize as a staple food has resulted to food insecurities in Kenya in some of the communities. The low yield of crop attributed to diseases and climate change is affecting pollinators, especially the honeybees. There's bridging of the gap by providing alternative food for population to reduce poverty levels. And there's also pumpkin is an economic crop. It can come in as an alternative food in Kenya that can be adapted, because this pumpkin plant is adapted to most agroecological zones like the arid and semi-arid regions like Machakos County, where I did the research. Farming of fast maturing crops that takes 3 to 4 months in the fields can also be done, and alternatives to augment feral pollination services by introduction of managed pollinators. The main objective of my research was to determine the seasonal floral structure utilized by honeybees in Machakos County, Kenya, specifically to assess the abundance and diversity of flowering plants in pumpkin farms at Masinga and Yatta sub-counties, which are based in Machakos County. My study area was in Machakos County, and this research is part of the bigger research that was done in Machakos County, which lies as per the information given. And this, more specifically, Yatta and Masinga sub-county, that's where the research was done on the small-scale pumpkin farmers who offered their farms to be used for the research. The research was done in low and medium landscape vegetation productivity classes based on satellite-derived NDVI. I had 32 farms, 16 farms in the low NDVI and another 16 farms in the medium NDVI. The red spots are showing the areas that were identified that had farmers that were farming pumpkins. The study was conducted in 2 cropping seasons. That is when the farmers were growing their crops, and we requested them to plant the pumpkins alongside their other crops. That is in October 2019 to March 2020, and the second season is in April to August 2020. Random sampling was used to establish 2-meter quadrats in the middle of the pumpkin farm, and another site, that's a belt transit 4 meters by 50 meters from the middle of the farm towards the non-farmed areas. In these 2 sampling sites, I identified plants on the farm, and both in the quadrat and also in the belt transit. So there are some that I was able to identify on the farm, and those that I was not able to identify, I brought them to the NMK herbarium so that I could be able to identify them, and then the plants were used to develop an annual chronological calendar. And that is the work that I was doing. The first photo, that is one of the farmers who offered her farm to be used, and you can see, other than the pumpkins, she has some pigeon peas that are growing in the farm. And on the far end, we have one of the farms that had the pumpkins that were mature. The data was analyzed in R software version, and this was done to determine the relative abundance, species richness, evenness, diversity of plants was done by Shannon-Weaver Diversity Index. The results, these are some of the plants that I was able to come across when I was doing the research, both crops and also some that are non-crops. The plant percentage abundance from the graph, I found out there was a higher percentage of plant species that was recorded in the low NDVI, as you can see in the photo, in comparison to the medium, in the graph, in comparison to the medium NDVI. And in the low NDVI, the popcorn cassia plant was the one that had the highest percentage of 55.8, and the lowest one was the common bee. Then in the medium NDVI, the passion fruit is the plant that I was able to come across that had the highest percentage, and the Mexican marigold was the one that had the least. And from the research, I found out that most plants that were observed both in the farms and around the farms were from the families Leguminosae, Euphobiaceae, Labertiaceae, and Anacardiaceae. Then the results, the frequency of plants observed differed significantly among the plant types, and also between the NDVI classes and across the months. Then from the results, I was able to come up with the floral calendar, and from the graphs we have the blue lines representing the total number of plants that were observed in the months that I was able to collect the data. The flowering plants shown by the orange line and the gray line showing the total number of flowers. So in low NDVI, in February had the highest total number of plants, flowering plants, and total number of flowers observed. In the medium NDVI, had the highest total number of plants observed in February and the least observed in June. Then the last line, the least number of flowering plants observed in July, August, and in January in both the low NDVI and in the medium NDVI. So my discussion, there is optimal pollination success in coffee. Optimal pollination success in coffee is very much dependent on bee species richness. Then addition of floral resources to natural landscape normally attracts wild bees, and also increasing wild bee abundance, diversity, and richness will increase pollination services in the adjacent croplands. Economies of foraging by honeybees are optimal when floral resources are next to the nests. The results agree with findings of Robinson that most plant species are biennial, perennial, and annual producing pollen and nectar within a short temporal window each year. This can be used to develop the floral calendar. In conclusion, the study shows that flowering plants other than crops play a very key role in providing floral resources to pollinator crops such as pumpkins. The best NDVI was the medium, which had the highest total number of plants and also the highest number of flowering plants, and also plants that had flowers. And the most abundant plant species that was observed was the Senna didyomobotria, and planting of flowering plants within and around crops serve as an excellent pollinator reservoir. Farmers should be encouraged to do agroecological practices to increase the abundance and diversity of flowering plants within and around the cropping area. There's a recommendation of conservation of the buffer plants and also weeds within the farmlands, and if possible also around the farmlands as a refuge for pollinators. There should be increased capacity building of farmers to understand the importance of flowering plants and bees in their agricultural production. Thank you for listening to me, and I'd like to acknowledge the following institutions. Thank you.
Okay, thank you, Maristella, for sharing your floral calendar in parts of Machakos County. Let's clap for her. So I don't know if Nicholas Jue is in the house. So I think we are going to skip. Then we'll move to David Murithi from KEFIS.
Good afternoon. Yes, my name is David Murithi. I think my presentation was more of a poster, but I found myself in this, so I have just to present. Thank you. So, I took the theme of the theme, which is conserving pollinators through research, education, and citizen science. And first we start with the importance of pollinators. As you know, we have various pollinators which are very crucial for production of food and biodiversity. They support the reproduction of many plant species, and without these pollinators, our crop would fail and the ecosystem would collapse. This means that there would be a decline in the globe food security and the natural ecosystem. Therefore, it is important that we understand the importance of conserving these pollinators so as to have a good ecosystem and a diverse biodiversity. There are various threats that these pollinators are facing, which include but not limited to habitat loss, and exposure to pesticides. Utilization and agriculture, urbanization and agriculture have led to destruction of the natural habitats of these pollinators, and most of the chemicals us as farmers we are using in the farm has also led to the death of the pollinators, as the pesticides are toxic to the pollinators. Climate change is another problem that has led to the decline in the pollination in the pollinators. Pathogens such as the arthropods, such as some feed on the pollinators such as bees. The role of research in conservation. It is critical to understand the ecological dynamics of pollinators. The studying of the health, the behavior, and the environmental impacts are essential to effective strategies of conserving the pollinators. The research will help in identifying the challenges and develop sustainable solutions for pollinator conservation. Scientific guidings will also help the policymakers to preserve vital habitats and restore the ecosystem. Yeah. Habitat loss and the restoration. That habitat loss means that this is the destruction of the natural habitats, which are the residing place of the pollinators. Therefore, destroying these habitats will lead to a decline in the pollinators. Yeah, on the educational initiatives, it is good we raise awareness about the importance of pollinators. We engage all people of all ages, starting from the children to the youth and to the older generation, so as we teach them the lore of pollinators by promoting environmental friendly practices to avoid the loss of pollinators. Yeah, the role of citizen science. This is an innovative approach to pollinator conservation. It involves where you you involve the public in data collection, research, and monitoring activities, which could lead to development of good strategies to preserve the pollinators. This can be done through engaging the school, by educating our future generation about pollinators, by having school programs with hands-on activities and citizen science program. Engaging students in outdoor activities and learning will promote a connection with, between the children and the nature. Yeah. Community events and workshop. This will enable to create awareness and engage the public to provide them with hands-on learning and participation in conserving the environment, which will enable in preserving the pollinators and creating pollinator-friendly gardens, which will increase the number of pollinators in our field and lead to increase in biodiversity. We can also use the online platforms, such as the social media, to ensure that we cover a wide and diverse audience to raise the awareness about the conservation of pollinators, and this will enable us conserve the environment. Also, the collaborative effects for sustainable future. This is where you put effort between the researchers, the educators, and the public, so as to come with strategies to address various aspects of conserving the pollinators. Together, we can create a sustainable future that supports both pollinators and people. These are my references. Thank you.
Thank you, David, for sharing how research, education, and citizen science can actually help us in conserving the pollinators. So I'll call again Esther for the second presentation. Or Adelaide, you want to go first? Yeah, okay, Adelaide, yeah.
Yeah, good afternoon. I would like
like to present to you the significance of citizen science in museum and schools by involving schools in urban habitat research for pollinator conservation. Citizen science has been relevant to museum and schools. It addresses several environmental challenges, but we can see that this science started long time ago. For example, in Tanganyika, during ornithology collection expedition done by SPEC and grants in those years, they involved several local communities in collection of birds. And in museum, we have all the collection of birds collected during that time. So they use citizen science to collect those types of birds in the different areas in Tanzania. We can use citizens through collection, identification, analysis, and data presentation using modern technology. And most of our activities of the museum functions such as education, environment, monitoring, dissemination of scientific results are using citizen science. And this presentation, my study, is the outcome of the joint 3 years Lepidoptera pollinator projects done in collaboration with NMK, Uganda, and Tanzania. So I would like to acknowledge the guidance of Dr. Esther Kioko in this project. And the objective of this study aims to assess the significance of citizen science in museum and the schools and its potential source of data on urban landscape for survival of pollinators. Now, I would like to ask myself 3 questions here. Why we use general public? They have technology. For example, here we see the media people taking some information from the scientists, but they have some information. They can give researchers useful information so that we can conduct more research and explore the environment. But even the public also explore some of the issues in the environment and disseminate those information to the museum and the research institution. And why my focus is on urban ecology. Why urban? Most of urban areas are regarded as buildings and the garden, and most of them in buildings and even recreation areas. But we separate the urban ecology from national parks, from forests. But have a lot of biodiversity. For example, in Dar es Salaam, it's part of Eastern Arc area and even the forest, the coastal forests. So they have a lot of biodiversity we can be proud of. And if we concentrate of doing researches in these urban areas, we can identify a lot of biodiversity which are still understudied. So the research, the study was carried out in Dar es Salaam City, which is globally important biodiversity because it's within the East Arc Mountains and East Africa coastal forests. And the study focused on 3 municipalities, Kinondoni, Ilala, and Temeke. Temeke, there is a Pugu Forest Reserve, but in Kinondoni we have Pande Forest Reserve. Ilala is mainly dominated by buildings, but there is an ongoing project of ensure that the area are well conserved in terms of planting trees and gardening some of the areas. Study approach. It was anticipated that strategies of restoration of habitats and indigenous plants to enhance and sustain beneficial pollinator population are needed and can be started from small scale such as having butterfly gardens. So in museum, we design butterfly gardens, and we invite some schools who came to the museum to learn how to design these butterfly gardens. And just at the beginning of the project funded by GRS Biodiversity Foundation, we set up a butterfly garden in the museum, and we focus on two main butterfly families, Papilionidae and Hesperidae. And before they engaging ourselves to schools, one day seminar was held with the school teachers to establish research design, analysis approach, and implementation logistics of the museum school citizen science. We select 9 schools in the 3 municipal councils in Dar es Salaam. And these municipal councils have different degrees of environmental disturbances. And the selected schools was based on ability to identify butterfly, to list requirements for established and design butterfly garden, carry out sampling, and willingness to host the study. We take coordinates in each school, and we employ standard method to all schools. Data collection took place for 8 days in long rains and short rains, and we use visual observations during the clear sky, good weather, to identify butterfly pollinators in each school garden. But museum researchers visited the schools 4 times for verification and also for monitoring. And of course, we create some cards with the colored photos of butterfly for easier identification of butterfly in the garden. But even the students take their photographs of the birds, of the butterfly visiting the garden using their mobile phones. We record some important informations, for example, time, dates, types, and species of butterfly visited the garden. We found 33 butterfly species observed in school gardens, 8 species of swallowtail butterfly, and 8 skipper butterfly, and the 17 other species of butterfly. But because our focus was mainly on swallowtail and skipper butterflies. And it seems that like a large number of butterfly pollinators were observed on all 3 schools located in Kinondoni, followed by Ilala, and lowest at Temeke Municipal Councils. These are the species we identified in school gardens. And there is also difference in school gardens in the 3 municipal councils differed significantly in total number of butterfly species observed. School in Temeke had fewer butterfly species than Ilala and Kinondoni. And most of this year is attributed to the environmental destruction caused by increased human activities. For example, in Temeke Municipal Council, there is a lot of human activities such as garage, etc. In Kinondoni, the high number of butterfly pollinator species were observed than Ilala, but this was non-significant. We have this flower, Western Indian jasmine, Lantana camara, verbena, which were grown in school gardens, showed significant in the total number of butterflies visited the gardens. Okay, and butterfly were significantly affected by flower shapes and colors, as we have seen here, the Western Indian jasmine and Lantana camara. So the flowers with the broad area where butterfly can land, they are most preferred by butterflies. Conclusion, citizen science is an important tool in formal education curricula to teach science inquiry and improve learning experience. And we learn that it enhances existing museum collection for further reference. we done also only observation and count, but maybe we can use this method to collect even museum collection through involving school children. It provides baseline data for town planners. You know, our cities are growing, so we think that if we use this kind of citizen science to collect some data, and this data are useful for town planners when they construct roads and even other infrastructures within the city. Citizen science should be applied in broader scale to boost the public interest in science, to contribute to conservation of urban ecology. But there are some challenges we are facing of identification. So basic identification skills should be developed in order to have quality data and eliminate limited knowledge in taxonomy knowledge identification. It is therefore recommended that regular community engagement and monitoring be conducted for appropriate quality data on temporal and spatial coverage. Well, I thank GRS Biodiversity Foundation for funding this project, and Dr. Esther Kioko for her continuous guidance in this project. Thank you.
Thank you, Adelaide, for sharing the Tanzanian perspective on how citizen science is being used to conserve the pollinators. So we don't want to lock any presenter out. I want to call the last time Oliver Genga. Okay, David Muridi. Not David Muridi, that is Nicholas Njue. Okay, Esther, maybe I will call you to make the final presentation, then we'll go to Q&A before we wrap up the session.
Good afternoon. As he looks for my presentation, just the same place where the first one was. I'm just again delighted to stand before you and make my second presentation. Alex, we had saved in the same folder. Okay, and this one will now highlight the importance of reference collections in understanding the crisis we are facing with the pollinators. And we have here at the National Museums of Kenya a huge collection of insects, and our insect collection is one of the largest in tropical Africa, south of the Sahara. He has found it, thank you. And this collection so the topic is on how we can use the museum collection to understand the pollinator diversity and distribution. So as we have already said that and also my colleagues have talked about the decline of pollinators and also the scarcity of data that can help us understand and address this crisis. So we have the natural history collections, and we have, these form a very unique resource because the localities where they were collected, most of them, the landscapes have changed. Also the times that they were assembled, we cannot go backward, so we can't go back. So this forms a very unique window into the past. I've just shown here, my colleagues have talked about Hesperids. These are skipper butterflies. So I just put one here so that you can see when we are talking of collections, what we are referring to. So this is also another collection. I've just shown the storage cabinets. We have cabinets, wooden cabinets stacked together, and when you pull out a drawer, you can find collections. So this one I just pointed to show the hawk moths, and these are very swift moths that are very key in pollination. So, as I've said, they are stuck in those drawers. So if you want to look, for example, for the hawk moths of, say, Kakamega forest, you have to go pulling all the drawers of the hawk moths and removing the label so that you can see where these moths are collected from. And that endangers the collections because, as we've said, some were collected in the past, you can't go back. So if you destroy this specimen, you have actually destroyed the heritage that we have. So we started this process of digitizing so that we can remove this information, have it processed, and have it accessible and managed. And then when it is accessible, we can be able to update. And also, when we move this information and make it digital, then it is easier to keep our collection safe without pulling the drawers each and every other day. So we also now, as we go out, like I showed, we have been doing some work in the Tana Delta. When we come back, we now also digitize the new collections from the field. So because, as I've said, we have about 3 million of invertebrate collections, we have to prioritize. And we say that because of the current crisis on the pollinators, we prioritize the butterflies and, just go step by step. In my previous presentation, I said we have 5 families. So in this project, we just started with 3 butterfly families and the hawk moths. I just pulled again this one here, just to show you why the hawk moths are very key. And also the butterflies have a similar mouth pad. We call it the proboscis. When it's flying, it coils it so you can't see it. But when it's landing on a flower, it throws it out. And maybe just a memory of you, some of us did some biology and we were told about the pollination of orchids when Darwin was going around and he found a very, an orchid with a very deep flower. And he said there must be a creature somewhere that has a long mouth part that can reach the bottom of that flower to pick nectar. These are the guys. Okay, so when we are digitizing, we pick the collection, like this is a butterfly, a skipper butterfly. We pull out the label. We collect that information from the label, which shows the locality, who collected it, and what date. We have collections as far back as 1880, 1840, so you can see why we are saying it's a very unique window into the past. And most of our collections didn't have the catalog numbers, so as we are capturing this information, we are also giving our collection unique identifiers. So what have we achieved so far? I said we are focusing on those 3 families. So with the papillionid butterflies or the swallowtail butterflies, now we have published over 7,000 occurrence records. You can go to this website, you see them, or if you just say swallowtail butterflies at the National Museums of Kenya, you'll get that information. We've done 9,000, slightly over 9,000 of the skipper butterflies, and over 10,000 of the Lycinis are the white, the blues and coppers, little butterflies, and then also the hawk moths. We've done 5,000 plus occurrence data and published. So what are some of the challenges? Some people have said that to actually digitize one specimen, you need about 9 minutes. So the records I've showed there, it wasn't done overnight. So if, like the first one, if you divide that 10 minutes each, you can see how many days and nights we have spent in the collection room. But that is okay. As we do that work, we face a few challenges here and there. Some of the, as I said, you can find a specimen that was collected 1880. And you can ask, how old is our museum? It's about 110 years now. But some people who came here early collected, naturalists, and when Kenya got independence and a museum was established, they donated the collections to the museum. So we have that, and some of these creatures are fatty. So the fat drips onto the label, and then it's not very easy to read, but we try. I said these specimens are very brittle, so if somebody is careless, we can get some breaking. Of course, names have changed, localities. When my friend Adelaide talked of Tanganyika, maybe the young people don't know what Tanganyika is. It's the current Tanzania. So you can imagine when I have people like Jane, who were born just the other day, and you tell them somewhere, they will be like, huh, where is that? But anyway, we are somehow trying to look at those gazetteers and helping trace the proper names. Taxonomy, dynamics. Again, Adelaide has talked about the challenges in taxonomy. Taxonomy or identification processes are very dynamic. Today, you'll find this butterfly, the skipper here, being called Colliedis forrestan. Tomorrow, somebody will come and say, no, this was not done properly. It's now Colliedis, maybe grassland or something. So we have this challenge, but we are also managing because we keep updating the taxonomy of the collection. So in conclusion, I've just picked that map, which is from the GBIF, and I've shown that if you look, very little information on Africa. You can see a lot in North America, Europe. But what have we done? At least we are now bringing the information about our collections, about our diversity into the world map. It can now be easily accessed. And with this, now we can be able to refer to this information and also enhance the accessibility of this data that has been locked up in this museum. And this data is very important. It can predict the past and help us to understand the present and also plan for the future. And with that, thank you so much for listening.
Thank you, Esther, for sharing with us on how we can be able to access the over 3 million plus collections within the museums. I think that's something very interesting from 1880 to date. So that's quite a good collection of specimens. So now I'll open the floor for Q&A for the 8 presentations from the 7 presenters. So anybody who has a question, you can direct it to any of the presenters in no particular order. Let's start with them. Yes, Prof.
Okay. I'm Suresh Raina. No, I don't need this. I think I can talk loud. Huh? All right, okay. My question is for my dear student and the chief of this organization, Esther Kiyoko, whom I met 32 years ago here in museum, and she was showing me the drawer of butterflies and moths. And I just selected her for my PhD program. My question is to you as well as to the candidates who presented the citizen science, right? More or less the common question. Do you have any breeding stations, or do you have planning to do the breeding stations for the important species of butterflies so that you can enhance the population and the pollination services and the biodiversity in the region? And why don't you include that in your citizen science as well? Because I think there is something you have said about citizen science is dissemination of scientific results. So the best part is if you do the breeding of these, you can increase the number of your pollinators. And even you can remove some of the species which are in the red list and release. And this you give to the people to do it, to earn money. And this is mostly happening in India and China, right? When we give results to the citizens, to the villagers, we give them full ownership, all facilities, they breed the whole thing, they release. We get the results, we only collect data. We don't take money, they are the ones who earn money. So that way you can solve the problem which you are facing, that some are getting extinct and some pollinators are less. So breeding stations at every national museum is very important.
I think that one for Adelaide and Esther, maybe any of you can take a jab on that. Anne, you want to?
Project, and I wonder why it's hard to hear that it has been replicated elsewhere. Or maybe they are. I think it's good to hear that. There are not enough incentives for people to adapt, especially now where people are relying on natural resources with climate change. It's going to be harder for survival of people. So some of this information, how can it be turned to alternative livelihoods where people can benefit? And I think also listening that, I think, yeah, we've heard a lot about insects, but I'm also thinking of Kenya Wildlife Service, but also the agriculture sector, especially who work closely with the farmers. How is the different information linked, especially I think when people are training farmers, do they even get enough information or facts to actually share the right information for people to adapt as they do their livelihoods? Thank you. So I think it's general. I think it's open to any of the presenters to answer that.
Yeah, I think let's handle those two questions first, then we move to the next. So Esther, Adelaide, you can try.
Okay. Thank you. Thank you, Professor Raina, for those insights. I think it's a very good idea. The only breeding that we've done is for the butterflies at the Kipepeo project, but by the communities. And I think it's a challenge to us as a museum to enhance more. She has asked about the replication. I'm happy to inform you that we have other farmers, like in Taita Hills, where most of the work we've done on the hawk moths and butterflies. We have youth groups who are rearing butterflies for sale. And also, as a museum, we've done the first handbook for butterfly farming in Kenya. And we've also done the first guide to the butterflies of Taita Hills. Yeah.
Yeah, thank you, Dr. Maybe Adelaide, you want to add something before we go to the next question?
Thank you, Prof, for your question. It's a very constructive one. And really, currently we don't have a breeding station in the museum, but we established a butterfly garden. And when we sample, we conduct our sampling in Aman Nature Reserve in East Usambara Mountain. We collaborate with butterfly farmers who have butterfly cages in the Aman Nature Reserve, and we planned that maybe we have some of our cages in the museum, because we have open air museum, a station open air museum at Dar es Salaam. So we plan maybe we can have a butterfly cage, as well as to increase this butterfly garden, so that we can have more. We can enhance butterfly population in the ecosystem. Thank you.
Thank you.
Okay, thank you, Adelaide, for that. That's the Tanzanian side. So next question.
Yeah, thank you. My name is still to Adelaide. You indicated that you got several species of butterflies as you were doing your interventions in the schools. But I would like to know whether you had any link between the butterflies that you collected and the crops they pollinate, so that you could be able to give this information to the farmers and the schools as well.
Yeah, thank you for your question. When we visited, museum researchers visited the schools to verify the results obtained by students when observing the butterfly visiting the garden. They also we also conducted an interview to know whether they visit other kinds of plants. For example, the pawpaw, beans, and the sunflowers. So some of them, they told us that some of the butterfly visited is pawpaw, beans, and even these eggplants. So there are those, I mean food crops, which are also visited by butterfly during the study period. Thank you.
Yes, I have a question. Okay. My name is Alois Wambua, working for Farm Truck Coastal Limited, which is an IPM company. And in our research and development department, we
They normally kill, they use some smoke and fire to kill the bees. I think on my end, what I can say is could be we can it can be taken up as a gap whereby the farmers or the people who keep the bees for honey can be informed to have other alternative methods of harvesting the honey other than killing the bees for them to get the honey.
Yeah, I can add on that. This is Jane. I talked about the climate smart bee pasture, but still in Nyandarua there is a lot of pesticide application because it's an agricultural area. So they are doing a lot of cultivation and a lot of pesticide use. So when we are doing our beekeeping projects, the first thing we usually do is to sensitize the community, because we cannot tell them to keep off from doing what they normally do. And since they are doing that to maximize on their products, we now try to tell them the truth about the conservation of bees and how important it is to keep them safe from this pollution. So, and that's why during our studies, we always have experimental studies to showcase where areas without pesticides and where they are using pesticides, how are they yield? And they are able now to see it from the field, and they can associate. So this is not just going to tell them, stop doing this, and you're not giving them the solution to that. So our solution is to show them when you conserve bees by just planting what is these bees are relying on. As I said, the climate smart bee pasture, the bees will tend to come back and start foraging, and when they are foraging from these plants that you have planted, they'll also do the pollination to your crops. And the end results, it's better yield as compared to that other person who decided to use the pesticide, one which is costly, and at the end of it all, the produce will not as good as those which have been pollinated. Yeah.
Thank you, Jane and Maristella, for responding to that. So I'll take one more burning question so that we can bring this session to a close. Anyone with a burning question?
I just want to add to that,
Yes, ma'am.
to answer his question. What they have said is very correct, but the other alternative is you provide farmers with the Langstroth hives or local hives, right? So that they can harvest the honey on the ground. This experiment we did in Mwingi. When I started in Mwingi way back in 1997, 98, right? They were also doing the same thing, burning and all those kind of things. But when I left Mwingi, or when I left Kenya in 2017, they were having more than 4,000 box hives in Mwingi. And they have a big marketplace. So farmers, they need honey definitely, and they'll do anything to get it. Still they do that harvesting, but I told them not to kill. They just remove the bees, only what they kill is the small bugs inside the, like brood. But the rest of the bees, they fly out with the queen, and they form another colony. So it's not that they are burning and they are spoiling. And the alternative is provide them wooden hives. So that is the alternative.
Okay, thank you, everyone. So the time now is 1:34. Let's give another round of applause to all the presenters. I think I'll now call this session short.
Yeah, excuse. I think we have answered most of it. Just now. The immediate. You are still there is the generator. Yeah, we just rearrange ourselves from Novo. We take some minutes to discuss. And then, so I want to call upon all the discussant panelists maybe to come from that we can discuss. how they impact on the livelihood. And with me, I have the panelists to talk about so that she can introduce the whole matter, and then from there we pick it up. So this gadget is important for those who are listening
Okay.
online. Online.
Thank you very much, Dr. Kasina. I will start maybe by saying my name is Professor Florence Olubayo. I'm a retired professor from the University of Nairobi, nearly 2 years now. And I would like just to mention really the subject of the discussion. I'd say it has more or less been covered from the first day all along, and it was very adequately articulated by the first keynote speakers, and one of them is here, so we are privileged to have him. And I would like just to generally mention areas where insects play a role in our livelihoods as human beings. But before I do that, let me just say we know as entomologists that insects are more numerous than the human beings. So of course the population, the immense population of them alone will definitely have a big impact on the livelihoods of the smaller populations. And then to add to that, the species diversity is a lot, and of course we have been reminded by Dr. Kyoko, the vastness of insects. So the fact that there are so many, and in every environment you'll find insects. So they adapt to environment very easily. That means their impact on the livelihoods of the people living in those areas is immense. It's just that we have only scratched on top of what they are able to do and how they impact on us. All the way from being insects that we entomologists of the old style, we were only stressing on insects as our enemies in our agricultural production. But over the years, this has changed to show that insects are so vast in their diversity that it is not only pests that we should look at as entomologists. There are those that are what we call friends of farmers, that are our biological control agents. There are those that are helping in decomposing soil, and we have had presentations in that area to show how important they are. We have those that are food, and by the way, I think there's now increasing awareness of insects now as food. So the benefits are now looking like they are actually more than what we first learned as entomologists as enemies. So the vastness and the richness is so vast that we as entomologists are challenged. We need now to see how do we widen our studies to actually enhance the impact, the positive impact of insects instead of stressing on the negative impacts. So I do believe the panelists will now give us aspects, maybe different aspects of the different insects, but the usefulness is coming out as big. And of course, the session that we have just had brings in the impact on our agriculture in terms of pollination. So the usefulness are many. Another thing that I'd like to mention, maybe we can highlight it also, in terms of make studies into these different aspects of their usefulness so that we can enhance their impact on our livelihoods in a positive way. So let me leave it there for the time being.
Thank you, Prof. Let's go to Professor Cole so that she can tell us one aspect, just a single aspect that you can look at into utilization or understanding of insects.
Okay, thank you, fellow panelists. When I left, while I was at ISIPE, although I was not in Professor Reiner's lab, I was listening in from the sidelines and returned home and started our commercial insects curriculum. Because I realized people needed to be trained, but they also needed to be research. So being set in within a faculty setting, I decided I'll focus more on training and research. And over the years, that program has been very popular, and I can confidently say we have contributed to building the capacity of our district entomologists whose mandate is beekeeping. But we've now expanded into sericulture. We are now talking more about insects as feed and food. And all of these are meant to demonstrate the value of insects. So they are both direct and indirect benefits. Mostly we focus on the direct benefits like hive products, but there are also the more indirect ones in pest control and maybe pollination services, just to give an example. So much as we promote these, I think there's also a place for R&D for these, and then we can translate those into actions that people, communities can take up. We have a lot of a vibrant beekeeping industry now, and people are depending on bees for their livelihoods. But I think there's also room for other things. Black soldier fly has taken up, and so it's not just the economic or business side of things, there's also a place for R&D. And to demonstrate to people that, I think it's one way that people can begin to appreciate biodiversity. It's not always injurious insects.
Yeah, thank you. I want us, I'm just mixing ideas. Every panelist will be able to give out something. And now I want my brother Lamban. At least I know he has done quite a lot of work on mosquitoes. That's other kind of insect. So he can tell us a bit about other insects, apart from agricultural insects.
Okay, so I'm already introduced. I'm Laban Njoroge. I work for National Museums. I'm an entomologist, meaning that I deal with insects. Well, I deal with mosquitoes sometimes, but they're not eaten or, or otherwise. So we know them for other reasons. But that doesn't mean that that's the only thing that I do. I deal with other insects. And I would like to give another perspective to this discussion. Every time we talk about invertebrates, and I would prefer the word invertebrates instead of insects, because invertebrates is much wider, than insects. And we do have relatives of insects that are of, interest to this discussion, but they're not necessarily insects. Things such as scorpions, things such as earthworms. They are not insects, but they are of, importance to what we are going to discuss. So everybody will talk about insects as food, probably that's what came into mind when you're coming to this discussion. And that is okay, but we have a much, broader application of invertebrates. I'm now careful not to use the word insect. Yeah, than just food and feed. So my main interest in the whole thing is tourism and if you think of tourism and things such as sport fishing, I know that doesn't, come into mind. Yeah, you probably don't think of sports fishing when you're discussing invertebrates. But I've been rearing, invertebrates for application in sports fishing, especially in Lake Naivasha, where people go to do the fishing for fun. And in most cases, these people would look for, say, earthworms in nature. Yeah, but then if you provide these things and they are readily available, people will buy them. Yeah, people will buy them to go and do the sport fishing. Still, in tourism, we have things, and Dr. Kioko would agree with me, we do have a lot of species of butterflies and other invertebrates like dragonflies that are very endemic to our region, that are very endemic to only certain regions within within our country. A very good example are the butterflies that you find only in the Taita Hills. Yeah, I don't know whether in attendance people knew that we do have dragonflies. These are aquatic insects that are globally only found in Mount Kenya and the Aberdares. A very good example is the Kenya jewel. Even the name suggests, that is only found in Kenya. And not in Kenya, but in the Aberdares and Mount Kenya. This is a very beautiful damselfly. It's aquatic, so you only find it in the rivers and streams. And if you wanted to see it anywhere from the world, you have to come here. We also have the Mathai longleg, a dragonfly only found in the Aberdares, Mount Kenya, and Mau Forest and Mount Elgon, named in honor of Professor Wangari Maathai because it's a truly forest species. So when tourists hear of these things, they want to see them. Yeah, so I think my area is a little bit different, but it's all tied to the others.
Very nice, thank you. That's another perspective, tourism, transfer of knowledge elsewhere and bringing money in a different way using insects. Let me invite Dr. Mutiambai to also provide his remarks about this subject.
Yeah.
Based on your experiences also on particularly, you have done quite good work on pheromones and chemical ecology.
Yes.
Associated with insect control and all of that. Those are all insect perspectives.
Okay, thank you. Thank you, Dr. Kasina. Good afternoon, members. I'm Daniel Mutiambai from ISIPE, and I'm an entomologist, and I focus more on the chemical ecology. And just to give a different perspective, before I talk of the pheromones, there is a very recent aspect that is going on, especially the war at Ukraine and Russia. You all know impacted negatively on our fertilizer supply, and the fertilizer shoot up. But there's an insect that has come into play, the black soldier fly. And what is it doing? It's just utilizing the waste to clean our cities, our homesteads, to feed the livestock like chicken, and release the protein sources like the soya or the fish, which has been used to in animal feeds as the protein source. But of relevance and a different aspect is this insect is also generating organic fertilizer. And we have been doing some work on it and checking if we use this fertilizer, an organic fertilizer from the insect, how different is it from the commercial fertilizer? And we are finding that, in fact, this organic fertilizer is more balanced and is also making our plants have some better defense mechanism to themselves. That they secrete, as the insect that they molt, they shed off the hard skin, but the black soldier fly, it also digests the waste. It also produces a certain compound called chitin. And what chitin is doing, especially we have seen this in maize, and cabbage. There are unknown enemies that are underground, the nematodes, which we normally don't see as because most of the symptoms we see above. But when we apply this fertilizer to the vegetables, it is suppressing the nematodes from the below ground due to that chitin that the insect is shedding as it digests the waste. And so that's another very interesting aspect that is coming into play. And just to add some bit of the aspects of around the food, you know, insects like the locust, which was a menace, but we look it on another perspective, we find that insects produce certain compounds which have of medicinal values. For example, the locust has been shown to have the good cholesterol. You know, we all know cholesterol is bad for blood pressure and all that kind of the associated diseases. But we have shown that we can extract the good cholesterol, which will be of help to our bodies, from insects like locusts. And I think that is also another perspective, like a source of good supplements that we can use for our health. I think, thank you, I can stop at that.
Thank you so much. For now, let me welcome Dr. Ngoka. Has done quite good work on silkworms, but you don't have to talk about silkworms. You can talk about anything else. And everything, whatever you wish.
Good afternoon, everyone. Thank you for that, giving me a chance to talk about the silk. And let me recognize the people who really introduced me to silk, because they are all here. Wow. Professor Aina there, and then Dr. Kioko is there. They are the mentors of silk in Kenya, and they were the one who introduced me to silk. And today, I can talk about it, and they are seated. So thank you for that. And I think this silk thing is something which has not been known actually in Africa, but in Asia countries is a engine behind the economy, especially India and other Asian countries. So it's something which we can capture as Africa and venture into it. And this thing in Africa started actually in Kenya in 1970s and then died again until Professor Rain came and reinstated in year around early 2000, and that's where I picked it. So currently, we had the bobigs, which is popularly known, domesticated silkworm. And over the years also we introduced another silk moth, which is airy silk, which also can do well with castor. It feeds on castor. And I understand also there's a project which has been known so spreading about castor. So it's a project you can pick, combine with both the products of castor seeds and also airy silk. So it's something which can be captured around. And this started, we introduced airy silk in early 2016. And also probably recognized Kasina for picking up National Silkacha. I think is the one which started 2015. National Silkacha never used to be there. So it's good to see that now Silkacha can pick up easily. And with the collaboration International Silkacha Commission, I think we can have the next conference. We need also to emphasize on silk and invite International Silkacha Commission to hold a conference in Kenya. And that would be great to promote Silkacha is one of the livelihoods in Africa. And I think there's a time when we are pushing with that. So these are challenges for the scientific conference, the second, because this was the first one. So in the second one, we can emphasize on it and before that, so that we can promote more Silkacha in our country. Apart from that, we have also our indigenous silk, apart from the Asian silk, which is very important. That's wild silk. Those are grown in our villages. It's something you come across, but because it's so new, it's something you don't know, it's there with us. And something also linked to conservation and also linked to climate change. Because if you check some of the wild silk, they feed on the host plants, which are destroyed in the forest. I can pick an example of one of them, which feeds on acacia trees. It's a Gonometa species, and you find mostly in Mwingi, where Rena was mentioning. These acacia trees, Merivera, is a good one for honey, and also a host friend for Gonometa, which is a wild silk. So see that combination. I see the necessity of conservation need, because these species, they just feed on the leaves, and the bees feed on the flowers. And then the next thing is to avoid the charcoal burning in it. You recently had the experience of charcoal burning in Kitui County, is it? And that's where we have most of the plants, the charcoal burning and all that. So there's a lot in this silk. And also another thing, we go to Rift Valley, we have Acacia meanzi. It's also another plant which will be used for wood and other, the pots and all that. So there's a lot of link between the wild silk and conservation and the income. Another thing I can talk about, silk is about, not only think about silk as a purple, producing fabric and all that. We also think about silk beyond fabric. It does also have other byproducts within it. You can now get cosmetics, soaps, and other things. Along also the products within the host plants. We can have the berries, making jam, and make other nice products. So we can say silk beyond fabric also is a thing. Thank you.
Thank you so much, Daktari, for elaborating on the benefits of silk and silkworms. Now I want to take us to Tanzania, my sister. You can talk about some of the impacts of insects on human livelihood, so environment, economy, kidogo tu.
Okay, thank you. And I would like to talk about of insects as indicator of healthy environment, and as well as the mythology we get from the insects. When we did our research in Aman Nature Reserve, we also interviewed some of the local communities, and they see insects as a good indicator of healthy environment. When it rains, they see a huge number of insects flying from one direction to other direction. So that is and they told us that is a very big indicators that it is going to rain. So I can see, and when you come into science, we can find also this is true. It's true when we see some insects maybe available in certain type of environment as an indicator of a good environment. But there are some myths on insects. And as a museum, we also collected this information from different local community, and especially the artists. They provide some information that, for example, there is a certain insect which produces a certain kind of light. So they perceive that this kind of insects, the light they produced, it seems that we need to recall where we come from. So the light produced by the insects indicates that there is something we have to recall where we come from. So, and the light is produced by the insects from the back side of the insects, and the scientists used to, the artists used to they used these insects to imitate the character of the insect so that they can recall the history and even the information they get from their ancestors, so that they can they can reflect what they did from the past, so that they can rectify what has been done wrong in the environment. So I can say that in the museum we also document this information of insects from different people, and we use these stories, and when we use this myth and change them into scientific facts, we can get a real story about the insects and the role they play in the environment. And also we use some of the insects in the museum, for example, to teach students, example, when they came to the museum for classification, and even the general public, they do come to the museum for recreation, where we display, for example, in the exhibition gallery. So I can say that insects play a very important role, not only in pollination, but we have them in different aspects, like in artistic world, as indicator for environment, as well as in education aspects. Thank you.
Yeah, thank you so much. That's a handful of information. Now I want to invite Professor Raina to look at all aspects now. And being a professor not only for bees and silk, there are more aspects that you may want to elaborate.
Thank you, Cassino.
Yeah, karibu sana.
Thank you all for nicely presenting the role of insects in enhancing livelihoods. I'll go to the dragonflies. You know, like one of the PhD students, my PhD student, long time ago had done that. And we used to use dragonflies for biological control of mosquito larvae. You know, the dragonflies has 11 stages. You will be surprised to know that. And they have very big, claw. They just pull all the larvae of the mosquitoes. So to reduce the population of mosquito, we used to mass multiply dragonflies, all in the lake, and then release them in small ponds and other places, so that you reduce the population of mosquito. Second thing we used to do is about ladybird beetle. We used to mass produce ladybird beetle in the lab. That requires just a pumpkin, right? And a nice environment. And then you multiply ladybird beetles for controlling the aphids. Beautifully they control the aphids. If you release the ladybird beetle on the crop, they control the beetle. Now I was told not to talk about silkworms, but my students have already talked about silkworms, so I'll talk something new which we have started, which I have learned in South Korea 2 years ago. This is to make transgenic silkworms, right? Transgenic silkworm to produce spider silk. You know, spider produces silk from the tail region, right? Silkworm produces from the mouth, right? If you see spider weaving, you will see it moves the tails beautifully, right? And that silk is very strong. It can take bullet. Yes, it's the bulletproof jacket you can make from the spider silk. But spider gives very little silk. So what these South Koreans have done, they have used the gene editing method that is called CRISPR-Cas9, right? That is a gene editing method. In the molecular, whosoever is molecular biologist can know this. And they have taken the eggs of silkworms, and then they have extracted the DNA from the spider silk producing glands and introduced with a microsyringe into the thousands of eggs of silkworms. Now with the result, you produce male silkworm as well as female silkworm in the process. Then you cross the two. When you cross the two and when you get the cocoon, you get the silk which is very similar to that spider silk. And that silk is 10 times stronger than the normal silk and 6 times stronger than the Kevlar. Kevlar is a fiber which they use for making bulletproof jacket. So this is the new thing which I'm going to start in my center. I have learned this technology in South Korea. They are the first one who have started this. Chinese are also trying to do that. But we have not yet done it, but we have developed a laboratory to do that. It requires beautiful lab. So that is one very important aspect of silkworm, which I think Kenya can do that. Museum can do that. It's not very difficult. It's just a micro syringe you inject and extract the DNA. Everybody, Nelly knows how to extract these DNAs. We have, I taught her all those years. And this is what I'm going also to suggest ISIPE guys. See, they were always complaining silkworm has no research, no research. This is the research which requires. The second thing you do is produce collagen fibers. Yeah? More collagen, like you have to extract sericin from the silk gland to produce more collagen fibers, which is required for human use. You need collagen. You know, there's sometimes like my age group, they break all kind of things. Yeah, so then you need collagen, which is very useful. Yeah, because silk, if you see the silk chemical constituent, this thing, chemical composition, very similar to our skin. So when you wear silk, you don't feel that you are wearing silk. You feel, oh, am I okay? So this is another aspect. The third pharmaceutical one is the protein which is required. Yeah? So you can extract that protein from the silkworm. These are the aspects which are going on in Asian countries now, in India particularly. China is also doing it, and UK is also trying to do it, but South Korea is ahead of all, right, in this one. Okay, that is about the silkworm, so I have not talked about the production. Wild silk, they have done it. Gonometa species from Mwingi district. She's the one who did PhD on that. Goka is the one who got a tree once where we had about 50 or 60 Gonometa species. That was a beautiful tree. Yeah, and I still have that picture with me. So the rest, then I jump to the bees. Now bees are very aggressive here. Not like my bees in India. My bees are so docile, I don't even wear gloves. Of course, I put this one because you have to protect your eyes. The rest of the thing you don't. They are Apis mellifera or Apis cerana. They both are very docile and good productive bees. Now production we increase by changing the queens, right?
Yes.
I have about 40 hives in my station. The rest we have in the farmer's field. We cannot put more than 40 because there is no place. Only 7 acres of land is there in my research station. So 40 hives we select, which is the best producer and less aggressive. There are some aggressive ones also. So we try to discard those ones. And then we do queen rearing. Now in the process of queen rearing, you can also collect royal jelly on 4th day, right? And royal jelly, if you put lyophilizer, if you put the capsule making machines, and you have to put one pharmacy fellow because they don't allow us to do that. We have to have a registered pharmacy fellow to produce the capsules. There's a quality control aspect.
Yes.
I mean, those kind of things insects give for livelihood. You can improve your aggressive bees here. They are very, very aggressive. Mwingi bees we tried level best. Mwingi we used to do queen rearing, and we have changed many, many queens, but still they are aggressive. And I don't know if this continues, we can make them docile little bit. Yeah. So queen rearing is the best thing which bees, and then pupa. Pupa of the queen, you can make nice food out of pupa. It's a very good proteinaceous food. Even the pupa of silkworm, after you reel the cocoons, you get the pupa, and it's very, very, it has 40 to 45% protein, much more than your beef and chicken and whatever. So I take the capsule of this pupa because I'm a vegetarian, right? The capsule is allowed, but insect is not allowed. Okay, now there is another one, Xylocopa. Xylocopa, if you remember, this black carpenter bee, right?
Yes.
What I've seen in Mwingi during those days and Kakamega, when they see Xylocopa, they kill it. I told them, no, this Xylocopa is 10 times better pollinator than the bees. Bees are not the only pollinators. You have Machilidae, you have another families which are very good pollinators.
Yes.
You have 7 families, pollinators families. Epidae is one of them.
Yes.
Yeah? Xylocopa comes under Epidae, carpenter bees. So this is what I think you have to teach the farmers, that save it. Like if you put this one, if you breed Xylocopa and release in the tomato crop, because tomato is not a, tomato is a requires buzz pollinators, right?
Yes.
And then it will boost the production. Pollination is the best thing which you have to improve upon. Even the silkworms, they are very good pollinators of your, what do you call it? The lady was presenting, pumpkin.
Pumpkin, okay.
Because they have very long this thing, and they go and suck this thing. You can see even those flowers. The butterflies, they go and they remove it and beautifully suck the nectar from there. So these are the things. Now the insect you were talking about is fireflies, right? The firefly, that is phosphorus burning insect. It burns phosphorus at the tail end. And then when it burns, it gives a spark. So you get the light. Now this one, they have used this idea to burn the bomb. This insect has given that damn dirty idea, right? And bomb sparks, then mines, There are bees which also are used to detect minerals in the soil. And like minerals, how can you detect? If you check the honey and see the minerals in the honey, right?
Yes.
You know that is the soil
Yes.
from where the mineral comes from.
Contamination.
And also they are now trying to use bees to detect the mines with drones. So they put drones, and I don't know how they do it, but I've just read very recently one paper saying that they are trying to develop bees to detect mines.
Wow.
So that you release the bees, they go near the mines, and what to do, I don't know. So that is what all about. And thank you very much.
Thank you.
Today presenters were very nice, very nicely presented everything. And I'm also thankful to the organizers, to my dear student. I should not say student now, she is the professor.
Student of students. No, always. She has also made it now.
She was the most brilliant and very good student I ever had in my life.
She has really continued in that.
We should clap for her.
Thank you, members. We haven't finished. I want to take opportunity to just invite 1 or 2 questions, not comments, to the panelists. Don't make comments. We want the areas of clarification and all of that. One of the things when I want to tell people or to tell our politicians or our leaders the value of insects,
yes.
I tell them to look at Isipe. Isipe is an insect institution. And how much money do you think is coming to Isipe, or how much worthy is that institution? Because in Kenya, I think we don't have another institution that is specifically focusing on insects. And I think it is very clear. Insects have a lot of impact when you look at that angle, and the funding that comes in not only from the government of Kenya, but also other governments and institutions all over. Remember that we also export insects. Yeah, we have what we call Mediterranean fruit fly. The budget of Mediterranean fruit fly to manage it in in America is billions worth more than the economy of Kenya or Africa. They have very huge facility, the SIT, Sterile Insect Technique Facility in Mexico and in Guatemala. So insects, and that is our African insect. If you look at the African killer bee, the bee which is giving problems in Americas, that's a bee that we have promoted out. Yeah? It spreads the message that Professor said here, our bees are very aggressive. Now as entomologists, we need to find ways of making these bees easy to work with. I think that is a message that Professor says. He struggled to make our bees docile. He's still dreams about it. I am very happy. So I'm working on the bees, and I will be very keen to partner and progress your ideas about making these bees less aggressive. So I want to invite you. Mary Stella, we have Mary Stella, we have Dr. Mary, we have, who else wants to talk? Just to ask questions, no comments. So that we release. Okay.
Thank you, Daktari. My question goes to, I think it's Dr. Mutiambai who talked about the black sonja flies. You said that I imagine it's the maggots which are working on the ground as they release the chitin so that it can be able to work on the nematodes. So I was wondering if this is the fertilizer that you are carrying as a person who is consuming the final product. Will the fertilizer be having the flies, or how is it that now it will be able to continue working in my farm? And secondly, where is the source of the waste? Some people are saying it's human waste. I don't know. Maybe you can tell us. Thank you.
Okay, we'll receive questions, then they respond, and we can be able to.
Thank you. My question also goes to Dr. Mutiambai on the issue of the black soldier flies. My concern is, have you started mass production for the farmers? And if you are to do it, I can imagine the whole country, we're depending on the fertilizer from the black soldier flies. How much flies are you going to produce so that you can satisfy all the farmers?
Very nice. Are there other questions so that they pick and we wind up?
Thank you. My name is Eric. You know, once a politician has been given time, he should comment and do something. So I was sometime in Masai ostrich farm. There is some stages of insects that are very, very destructive. We have talked all of the goodness of insects, but we have not talked much about measures on how to control those harmful stages of insects. That's the larva. Actually, larvae came millions of millions. They ate all grass. And the manager said that we spray chemical and they kill them. But I told them by days they will be moths. They destroyed everything. And a few days, there is some also larval stages of some insects. They hang on trees. They ate all leaves of the trees. And once they finish the leaves of the trees, they go into the rooms. They walk all over the rooms. And once they get you into your skin, actually, it is very, very painful. I decided to call to ICIPE, but I didn't have any help. As far as now, Dr. is here, I think he will help. So what are the mitigation measures, control measures for that? Yes, please.
Very nice. That is should be the easiest. Another, the reason is when you talk about insects, we have always thought about control, isn't it? Our life has been, if you look at the budget of importing pesticides in Kenya, billions of shillings, you know. The chemical industry in Kenya, the pesticide industry, lot of money. Another question before I return to the, yeah. Please pick your questions. And it's good to ask across all the panelists. Possibly. It's good to.
Yes, thank you very much. My name is Oromo Koma Charles. I recently graduated from Makerere University, and I am currently drafting my proposal, which I would want to do at PhD level, which is investigating the effects of climate change and land use pattern change on the behavior, genetics, and ecology of stingless bees, Meliponula species in Uganda. I have one or two challenges that I am facing. One, I haven't got the funding which can make me do this, and two, I am also looking for an appropriate institution with the facilities that can make me do this successfully.
Oh.
Yeah, I am one of the students of Professor Anna Kor.
Yes. Now you are in the right place. Yes. Another question, so that I can give a panelist. So where do we start? Panelist who wants to go first to respond to all of those. One aspect, Mutiamba, you are mentioned specifically about that. You call it kiting.
Yeah.
How do you carry it?
Yeah, okay. Thank you for that question on the fertilizer aspect of the black soldier fly. So what happens is, you see the markets, or the waste, the organic waste that are generated in the markets, you give it to this insect, the handout fly. The handout is a fly. So it will lay the eggs into the waste. Then the larvae that emerges from the eggs will feed on that waste. As it feeds, it converts it reduces into pests and pellets and small particles, such that as it feeds, because insects, as they develop, they molt, they shed off the skin. So what happens is, once it reaches the fourth stage, the larvae becomes big, and you can use it to feed your chicken or fish or pigs. But you sieve off the big larvae, but you leave the skin that it shedded when it was developing. And it is within this skin, the exophy, that adds that chitin in it. So you can process that waste by grinding the waste that remained, which now mixes the exophy and the remains that were left of the feeding. And also, as insects, as they develop and as they feed, they are also excreting some waste. So all that combination is what makes the black soldier fly fertilizer. You don't apply the larvae into the farm, but it is the exophy and is excrete and the remains that remain as it digests the waste. And the second question was, where is the source of this waste? Normally, actually, we generate a lot of waste from the cities, the kitchen, schools. We have so many wastes that we are generating. And what is happening is we are dumping the waste into the dump sites. What happens? They smell bad, they produce the greenhouse gases, which are also contributing to the climate change. So what is happening, but it's becoming, has a bit of challenge, is we can collect this waste, especially the organic waste, if we can segregate the waste, the organic waste and the non-organic waste. And we use this organic waste to produce feed and also produce larvae. That's it. Okay. There are also some aspects where some research where the human waste has been tried, but that has some ethical issues, and this has not been yet accepted. And you see, it's just at the research level. And until the ethical aspect is approved, I think the human waste as per now is out of question. But we have so many waste around. Can we utilize this waste around? And so around that was how much insects are we going to use to produce enough fertilizer? So what has happened is ISIPE has trained many farmers. And actually there are some companies which have developed out of this black soldier fly. Like we have the Synergy, we have Savvy Organics. These are some of the companies that have taken out this idea, and they are producing tons and tons of fertilizer from the West. Actually, Synergy is just around Rimuru. It utilizes the waste from Nairobi and the metropolitan area, but it's not even able to finish the waste alone. And now currently we have a new project that we have been funded by IKEA Foundation, and what we are doing is we are trying to go into the municipalities and have like a hub and spoke, a hub such that within a municipality the waste can be collected, and we give the black soldier fly to act on it to generate the fertilizer. But we are using this fertilizer now to grow vegetables with it with the farmers. So and they are going to benefit. So the source is there. The only thing is the diffusion of the knowledge to the farmers and to the entrepreneurs, because Synergy has created a lot of jobs. So this is one opportunity we can use the insects to clean the cities and also create jobs as we get fertilizers and the feed. I think I can just say that on those two.
Kuna ingine? Okay, Professor.
Best. He's asking about the pest, right?
Yes, yes.
Yeah, the larvae that attack your trees, you should first identify. Without identification, you cannot do any control. You don't have to put chemical pesticides on that. Most of the larvae, they are attacked by nuclear polyhedrosis virus. So mass production of nuclear polyhedrosis and then spraying is one option. Second option is that if you have neem oil, you put neem oil as well as little soap combination and spray the whole thing. You see, the soap liquid actually blocks the tracheae of larvae and they suffocate and die. Plus neem also acts as a kind of killing agent. So you don't have to use the chemical pesticides to kill all the larvae. But first you have to identify the larvae. I mean, you are saying that thousands of larvae comes and eat the grass and eat that one. Now these technology will not harm anybody. Nuclear polyhedrosis will not affect human being, will not affect animals, anybody, or grass. Yeah, so that is another one option. But you should get that, and you can. It's a marketable product. You can get it, right? Then spray. You get rid of that. Now regarding the stingless bee man, where is this man? Yes. If you want to do mass production of stingless bees, go to ISIPE, write down the name Dr. Kiyotoko. Dr. Kiyotoko. When I was here, we developed some hives, which you can mass produce stingless bee honey plus stingless bees and all kind of. And the second thing, what was he asking?
Scholarship.
He wants to go
Opportunity to do PhD. Is it a PhD or master's? PhD.
Talk to Dr. Evelyn Guku in ISIPE.
Yes.
She's the scholarship in charge. I don't know whether she gives or not, I don't know, but she has
Give
the
her
scholarship.
She
Huh?
will give her, she will guide him. She will guide him.
Yeah.
Yes.
So you go to ISIPE and that will solve your problem.
Very
Thank
nice.
you.
Thank you so much. I think all the questions have been answered. I want to take this opportunity to thank all of us for being patient and listening to the panelists. I think, in my opinion, we come to the end of the panel discussion so that we can go and take lunch and follow up with other matters. Just before I close, maybe I could ask Dr. Kioko, in case you have an announcement or anything you want to say. We recognize our presence here and our leadership. Thank you. And this is for the partners.
Okay, thank you, Chair, for this opportunity.